Our software is a web browser-based application designed to analyze the Bank of Money network containing nearly 1 million computers. Our application focuses in particular on exploring multivariate data over time. The server side uses Flask microframework to perform aggregations on the data and to handle clients' requests. All data is stored in a Postgres database with multiple indexes to improve performance. Redis is used as a caching layer in which query and aggregation results are stored. Data between client and server is exchanged in JSON. The client-side application is built in D3 and can be run in most of the browsers. From the 2nd to 4th of February, the reports of the health status of the machines of Bank of Money are visualized on the timeline. The overall pattern over the whole period can be explored for the activity flag, the policy status, and the number of connections. The number of connections increases during the working hours for each time zone and decreases at night. For each main location and each time step, the size and color of the node on the map indicates the number of connections, or the policy status, or the activity flags as chosen by the user. We first look whether a possible virus infection can be detected. We explore whether policy status 5 shows up on the map by exploring each 15 minutes time step on the timeline. At 11:45 am BMT on the 2nd of February, the first possible virus infection is reported in the headquarters. By zooming into this location, we see that the amount of infected machines in this region increases over time. We identify that the first infected machine is a server with compute function with IP 172.194.20. Before the machine had the policy status 5, it had policy status 2 at 8:15 am, policy status 3 at 9:15 am, and policy status 4 at 9:30 am. After the headquarters are infected with the virus, we observe the increase of infected machines all over the Bank of Money, and the network never recovers. To explore how the deviation in policy propagates, we first observe the regional patterns for machines reporting healthy status. We can explore the distribution of activity flags for machines reporting policy status 1 for each region. As we explored those in time, we discovered that region 5 and 10 never report policy status 1. This indicates that machines in these regions already suffered from at least moderate policy deviations before the 2nd of February and never recover. To explore the normal activity of the machines through the time, we look at the number of machines reporting their status. The regions show regular patterns. While exploring the regions over time, we noticed that a large amount of machines stopped reporting in region 25. When graphing the activity flag over time, we clearly see the gap in machine activity starting at 11:15 am on February 2nd. The gap starts forming slowly and takes a sharp descent at 12:15 pm. Around 4:30 am on the 3rd of February, the anomaly is gone and regular pattern found in other regions reoccurs. An interesting finding is that the downtime does not seem related to maintenance. This anomaly could possibly be caused by a sudden electricity blackout. We have also encountered a reporting anomaly in headquarters region. Comparing to other regions, the headquarters pattern differs. At first available time step, on the 2nd of February, the number of reporting machines is lower than at the same time step the next day. The significant increase of machines reporting occurs on the same day at 6:15 pm. In our visualization, the headquarters region is however an aggregation of the headquarters and the various data centers. Since we don't know the regular pattern for the headquarters, we can't discern whether the added machines should normally be on or off.